So hello everyone, this is lecture 40 for the mathematical physics. In the last lecture we were discussing about the multiply connected region, and I told you this thing that if there is any simply connected region and you inside you have a non-analytic region, then any loop around it will give you the same value. The integral of this around any means this region, any contour will give you the same value. So this was same. Okay, and I told you how to check this value. I give you the proof. So now we will see some examples. So integral is given. This is contour C exponential z dz. In every question, contour will always be given. Like in this region, it is given that C is any contour, means it can be anywhere, any loop. So we know exponential z is entire function and it is analytic at all points in the entire plane. So this will be 0 according to the Cauchy integral theorem. Now cos z is also an analytic function in all the entire function, so it will again 0. Now z and dz, so we know for n equal to 0, 1, 2, this will be 0 because of the Cauchy integral theorem. Now I is given as sec z dz, and contour is given as mod z equal to 1. Now what is the meaning of mod z equal to 1? This is a circle of unit radius. So see, this will be your circle, this is your contour. Now it can be written as 1 upon cos z. Now cos z is this 1 upon cos z is non-analytic at what points? When cos z equal to 0. So cos z equal to 0 will give you z as plus minus pi by 2, 3 pi by 2 and all. Now see if these non-analytic points are lying inside this contour or not. If they are lying inside, then we have different value and if they are not lying inside it, then this whole region is analytic. Then according to Cauchy integral theorem, this will be 0. So see, pi by 2 will give you 3.14 divided by 2, so it will be 1.54 something. So this will be outer of this, means 1 will be less than this, means pi by 2 is greater than 1. So 1.54 will lie here and minus 1.54 lie here. So contour is free from any non-analytic point. So that's why this will give you 0 for this contour using Cauchy integral theorem. Now let's see this contour 1 upon z square plus 4 dz equal to 0, and contour as given mod z equal to 1, again unit circle. So now this is non-analytic at what points? At z square equal to, is this whole term should be equal to 0 and z should be plus minus 2 iota. So see, in this unit circle, this plus and minus 2 iota will lie on this side, on this side. So they will be out of this contour. So again this function is analytic in this contour, so that's why this will be 0 according to the Cauchy integral theorem. Now 1 upon z minus 3 iota dz, contour is given as mod z equal to pi. So circle is of pi radius. Now see, this is non-analytic at point what? Z equal to 3 iota. So see, this 3 is less than pi, and it will lie somewhere here, means this point is lying inside the contour and this is a non-analytic point. Now it's a multiply connected region. So how you will solve this? So 1 upon z to the power n, or z minus z naught to the power minus 1. So how to solve this? I already told you this. When you have this kind of form, z minus z naught to the power n, and n is minus 1, so integral will be 2 pi iota. So it is again the same form, z minus 3i iota will go to the numerator and it will be z minus 3i to the power minus 1. So n is minus 1, so this will give you 2 pi iota. Okay. Now let's see one more example. Contour is given like this region, and 1 is lying inside this contour. And question is 2z minus 1 divided by z square minus z dz. Now see, you can divide this in the z minus 1. Now using the partial fractions, you can write it this like this: a by z plus b by z minus 1. Then comparing, you can find the value of a and b. So a and b will be 1. Now this whole integral can be written in this form: 1 upon z integral and 1 upon z minus 1 integral dz. Now see, to solve this integral, it will be z to the minus 1. So n is minus 1, so this will give you 2 pi iota using the same formula. And z minus 1 is also z minus z naught to the power minus 1. So it will again give you 2 pi iota. So value will be 4 pi iota. And because z equal to 1, at z equal to 1, this is non-analytic. So that's why we are writing this. And again z equal to 0 is also lying inside, and at both these points, z equal to 0 and z equal to 1, these functions are non-analytic. That's why we are getting these values. If 0 and 1 were not inside this contour, then these integrals will be 0 using the Cauchy integral theorem. So but now they are 2 pi iota, 2 pi iota. You have to check this if this function is analytic or not, and if not, then that point should be inside or outside in the region. Then you will get your values respectively. Now let's see, this is our integral 1 upon z square plus 1 dz, and contour is given as z plus iota equal to 1. So what is the center of this circle? Center of this circle will be minus iota, 0 minus iota. So it will be in the this region. Circle will be like this down the x-axis. So let's see, this will be non-analytic at what points? You can write this like this, 1 upon z plus iota, z minus iota. This will give you z square minus iota square will give you z square plus 1 again. Now this can be written as in this form using partial fractions. To find the value of a and b, you will get this form. Now see, you have to integrate this 1 upon z plus iota and 1 upon z minus iota. See, this will be non-analytic at what point? It will be minus iota, and minus iota is lying on the contour, because this is yours, means not the contour, it will lying inside the contour, because this is the center of the circle. So the value of this will be, again it will be in the form of z minus z naught to the power minus 1. So this will give you 2 pi iota, and for this it will be non-analytic at z equal to 1, and z equal to 1 is not lying inside this circle, because this circle is in the downside of x-axis and 1 is in this here, somewhere here. So 1 is not lying inside the contour, so this will be analytic at the region in this contour. So using the Cauchy integral theorem, this will be 0. Now 2 will cancel out and you will get the minus pi as your answer. Let's see one more example. So I is 1 upon z square minus 1 dz, and contour is given like this. There are two contours now, means first is this, second is this. So let's see, we can write using partial fraction this as in this form, 1 upon z minus 1 minus 1 upon z plus 1, 1 upon 2. Now we will separate them, and we have to check for both the contours, both the integrals. So this is for z equal to 1, this is non-analytic. So in the right loop we will see that z equal to 1 is lying inside. So for the right loop its value will be 2 pi iota and 1 by 2, so it will give you pi iota for z equal to 1. But for minus 1, means you will see that this integral for this right loop is non-analytic at this point, that's why we are getting this value. But in this loop it is this function is analytic at all points, because minus 1 will also give you something. So this function is analytic in this whole contour. So we, from the Cauchy integral theorem, we know this will be 0. So in the left loop this is 0, for the right loop you have pi iota. Now see this one, in the right loop z equal to 1 is nothing, means this is analytic for whole the contour for this one. So this will be 0 for the right loop, and for the left contour this is non-analytic at z equal to minus 1, so it is lying inside. So you will get again 2 pi iota, but it is in the clockwise direction, so it will be minus 2 pi iota, and minus minus will give you plus, so this will be plus for the left loop. Now if you take this, so it will be minus this plus, so this will be 0. Okay, I hope you get the point. Means we have to check this if this fz is analytic or not, and if it is analytic in that region for every point, then it will be 0. If it is non-analytic, then we have to check if it is 2 pi iota or something else. Okay, means for the points inside we have to check this. So let's see now the Cauchy integral formula. So that was the Cauchy integral theorem. Now we have Cauchy integral formula. This is a formula to solve a particular type of complex functions. So let's see what type is here. If fz is analytic on a closed contour, so if fz is analytic on a closed contour C, and within the region bounded by C and z0, means within that region there is point z0 is any point inside the contour, then means we have this kind of function. and in this contour this fz is analytic at all points, but this z0 point is non-analytic in this region. Okay, means this fz is analytic at all points in that contour, and this z0 is non-analytic region, and z0 lying inside this contour. Then the value of this integral will be 2 pi iota f z0. Means just substitute the value of z0 inside this function, and this will be your answer. But see, if z0 is not lying inside this contour, then this whole function will be analytic in that region, in that contour. So it will be of the form of fz dz, where fz is analytic. So using the Cauchy integral theorem, this will be 0 for z0 is outside. So you have to remember this formula first, because we will convert every possible integral into this form, and then we will use this formula. Okay, so let's see one example how can we convert any function into this form. So the see, this is our contour. Contour is mod z equal to 1, means it's a unit circle. Okay, so using the, now see, this is non-analytic at z equal to 0 and z equal to minus 2, but z equal to minus 2 is not lying inside this contour. So this 1 upon z plus 2 will be analytic at all points in this contour, but z is non-analytic. So we can write it in the form of fz over z equal to dz, where fz is 1 upon z plus 2. So this will be in the form of our Cauchy integral formula. Now what will be the answer? This will be 2 pi iota f z0, and z0 is 0. So f0 will give you 1 upon z plus 2. So 1 upon 0 plus 2 will give you 1 upon 2. So 2 pi iota multiplied by 1 upon 2 will give you pi iota. Okay, so that's how you can use the Cauchy integral formula. Let's see one more example. Exponential square divided by z minus 2 dz, and contour is given any contour enclosing z0 2. So it can be any contour in which z2 is lying. So this is lying inside, so we will take this fz as e exponential. This is not a square, this is z, so exponential z. So this will be our fz, and this will be our z0 will be 2. So answer will be 2 pi iota fz0, so it will be e square, and it is in clockwise direction this contour, then it will be minus 2 pi iota exponential square. Now see one more example. Z cube minus 6 divided by 2z minus iota dz. Now it will be non-analytic, means what is the contour given? Contour encloses z0 I by 2. So I by 2 is inside that contour. So at I by 2, this function is non-analytic. So but this is fz, and this is z minus z0. So z0 is I by 2. So answer will be 2 pi iota f z0. So this will be your answer. Means you can solve this like this, and fz is z3 minus 6. Means here you have to take this divided by 2, because here you will take 2 common, then it will be z minus iota by 2. Then you will have the form which is used in the Cauchy integral formula. So z3 minus 6 divided by 2 will be your fz, and at z equal to I by 2 it will be non-analytic. So 2 pi iota f z0 will give you the answer. So use this here. Let's see one more example. Z square plus 1 divided by z square minus 1 dz. Now you can just make this a plus b, a minus b, and contour is given this. So 1 is lying inside. So we'll see that at 1 this will be non-analytic, and this whole function will be analytic. So this will be your fz, and at z equal to 1 it will be non-analytic. So answer will be f z0, and z0 is 1 here. So fz is this. At z equal to 1 it will be 2 divided by 2, it will be 1. So 2 pi iota fz will be 1. So 2 pi iota will be answer. Now if this contour is given in this side, means circle was this side, it will be minus 1 lying inside. Then this will be non-analytic point, and this whole function will be taken as analytic. So you will take z equal to minus 1 here this time. Then 1 plus 1 divided by minus 2, it will give you minus 1. So minus 2 pi iota will be your answer if contour is something like this. And if you have contour like this, now minus 1 and plus 1 both are outside this contour. So this whole function is analytic in complete this region. So using the Cauchy integral theorem, this will be 0. This integral will be 0. Now let's see one more example. Tangent over z square minus 1 and mod z equal 3 by 2. So circle will be of radius 1.5. Now see, you can divide this in the using the partial fraction, tangent by z minus 1, tangent by z plus 1, and minus 1 by 2 plus 1 by 2. Now let's see if what function is analytic at all region in this contour. So tangent is non-analytic when cos z equal to 0. So z equal to plus minus pi by 2 plus minus 3 by 2. So pi by 2 is greater than 1.5. So the non-analytic points will be lying outside the circle for tangent. That's why tangent will be analytic in complete this region. So we will take fz as tangent and at z equal to 1. So this will give you again the Cauchy integral formula you will use here. So it will be 2 pi iota tan 1 here. So you will get the same 2 pi iota tan 1 and 2 pi iota here it will be z equal to minus 1. So tan minus 1. So after solving this you will get 2 pi iota tan 1 because this minus will give you plus here and it will be 2 pi iota tan 1. Let's see one more example. Z square divided by Z4 minus 1 dz. So here contour is given z plus 1 mod equal to 1. So here our center will be minus 1. So this will be your center. And if you write it in the expand this, so it will be z square minus 1, z square plus 1. And z square minus 1 can be written as z minus 1, z plus 1. Now see, for this contour, only minus 1 lying inside. So for minus 1, this will be your 0. So this whole term will be your fz because this is analytic in this complete region. So this will be your fz, and at z equal to minus 1 you will get the value by putting in the fz. So just putting minus 1 here, so it will be 1 over 2 and minus 2. So you will get minus 1 upon 4. So f minus 1 will be minus 1 upon 4. So it will give you minus pi by 2 iota. So this will be your answer. What if we change here the contour as mod z equal to 0.9? Then we will see that our circle will be contour will be lying like this, and 1 and minus 1 both are outside this contour. Both are outside this contour. So this whole function is analytic at all the points in this contour because it is non-analytic at only 1 and minus 1, and both points are outside now. So we will use the Cauchy integral theorem fz dz. So this will be 0. Okay. So that's how you can use the Cauchy integral theorem and Cauchy integral formula. We have seen enough example. We will see one or two more in the next lecture. Then we will move forward. Thank you everyone.